Somewhere beneath the field you will never visit, there is a footprint pressed into stone. It belongs to no creature you have ever seen. The toes are splayed wide, the weight heavy and deliberate, and the mud that once held it has long since turned to rock. 60 million years of silence sit inside that impression. No one mourns the animal that made it. No one remembers the rain that fell that morning. And yet the print remains perfectly still, perfectly patient, as though it has been waiting for someone to notice. Something older than curiosity brought you to this moment. Perhaps it was the same rhythm that once pushed mammals out from beneath the fern shadows after the sky turned to ash. Perhaps it was the same ancient pulse that told the first whales to leave the shore and trust the dark water. There is a memory written into your bones, not in words, but in calcium and collagen, in the architecture of your spine, in the forward-facing aim of your eyes. You carry 66 million years of dust inside you. Every breath you take tonight is borrowed from forests that no longer exist, filtered through an atmosphere that the dead rebuilt. What if the world you know, the one with its cities, its seasons, its familiar animals, is not the default? What if it is only the latest draft of a story the Earth has rewritten dozens of times? What if the silence after catastrophe is not an ending, but a door, and everything you call home walked through it? Tonight we stand at that door. On the other side is the Cenozoic, the age that began in ash and stone, and somehow across millions of years of patience produced you. Stay with me. Let's drift a little deeper. Close your eyes, not because I ask you to, but because the world we're about to enter has no electric light. There is no hum of machinery, no glass between you and the air, no walls to separate your skin from the breath of the planet. We begin not with a date or a number, but with a feeling. Imagine warmth, not the warmth of summer, or a room with the heater left on, but a warmth so total and so ancient that it does not feel like temperature at all. It feels like weight, like the air itself has thickened into something you could almost hold in your hands. This is the atmosphere of the early Cenozoic, and it wraps around the planet the way grief wraps around a house, after a funeral heavy wet and strangely still. 66 million years ago, give or take a breath, the sky was not blue, the way you know blue. It carried a faint haze, a veil of particulate dust and carbon that had not yet fully settled. The asteroid, that great uninvited punctuation mark at the end of the Cretaceous, had struck the Yucatan only recently in geological terms, and the atmosphere still remembered the impact. Not in fire anymore. The fires had died, the tsunamis had receded. The darkness that choked the sun for months, perhaps years, had thinned into something translucent and strange. But the air still held the memory of violence, the way old stone holds the memory of rain quietly in its chemistry, in its composition, in the way light moved through it at dawn and refused to sharpen into anything crisp. Picture yourself standing on a coastline in this newborn age. The ocean before you is warm, warmer than any ocean you have ever touched. There is no ice anywhere on Earth, not at the poles, not on the highest peaks, not hiding in any shadow. The concept of ice is a future the planet has not yet imagined. The water at your feet is bathwater warm, stretching to a horizon that shimmers with humidity, and the sand beneath you is dark volcanic in places mixed with organic sediment. The compressed remains of creatures that perished in the extinction and were slowly washed ashore over thousands of years. If you kneel and press your hand into it, it feels like powder and paste clinging to your skin and carrying a scent of salt and something far older, something mineral and nameless because no human existed to name it. Every breath you take feels full, almost too full, as though the atmosphere is offering more than your lungs were designed to hold. Carbon dioxide levels are far higher than anything in modern experience, and the greenhouse effect here is not a theory written in a textbook. It is a texture you can feel on your arms, in the dampness that never quite dries, in the way heat sits on your shoulders like a hand that will not lift. This is Earth, without contrast. Earth before the poles froze. Earth before deserts carved their pale scars across continents. A planet so warm and so uniformly humid that forests stretch from the equator nearly to the poles unbroken, dense, and impossibly green. Those forests are waiting for us, and we will walk through them soon enough, but first there is something else to notice. Something more important than the heat. The The silence, not the absence of sound. There is sound, yes. Waves folding against the shore, wind through leaves that belong to no species you would recognize. The distant call of something not quite a bird, not quite a reptile, something still deciding what it wants to become. Insects hum constantly, a low vibration that fills the spaces between every other noise, and small splashes in the shallows mark the hunting of creatures too new to have names. But beneath all of that, there is a deeper silence, the silence of absence. The great reptiles are gone. The thundering footsteps that shook this ground for over 100 million years have stopped. The sky once ruled by pterosaurs with wingspans wider than cars is emptier now. The ocean once commanded by mosasaurs and plesiosaurs is open and unclaimed. The niches are vacant. The roles, unfilled the stage, swept clean and waiting. In that silence, something extraordinary is happening, something so slow you would not notice it, even if you watched for 1,000 years. The survivors, the small ones, the overlooked ones, the creatures that spent 100 million years hiding beneath ferns and inside burrows are beginning to move. Not with confidence or purpose, but with the tentative curiosity of someone entering a room after a storm, checking the walls, testing the floor, unsure whether the ceiling will hold. Mammals tiny and warm-blooded, no bigger than your fist, creep through the undergrowth on soft paws. Their hearts beat faster than yours, quick, urgent little engines burning fuel to keep their bodies warm through cooling nights. Their teeth are sharp but small, designed for insects and seeds and whatever scraps the new world offers. They do not know that this silence is an invitation. They do not know the world is theirs. They simply do what they have always done: survive, breathe, listen. And the atmosphere listens back, because the air of the early Cenozoic is not passive scenery. It is an active sculptor, a participant in everything that comes next. The carbon dioxide it holds will feed the forests that grow. The warmth it traps will push vegetation toward the poles, stretching green into latitudes that will one day know only snow. The moisture it carries will fill rivers, swell wetlands, and create the humid nurseries where new species experiment with shape and size and ambition. Erosion is time thinking, and the atmosphere is time breathing slow, invisible, patient beyond anything a human mind can comfortably hold. Tonight, as you lie, wherever you are, the air around you is a distant descendant of that ancient breath. Thinner now, cooler, drier, carrying less carbon and less of that primal heaviness. But it is the same air recycled and filtered through the lungs of every creature that has ever lived on this planet. The oxygen in your blood tonight was once exhaled by a fern in a Paleocene swamp. The nitrogen around you has drifted through 66 million years of sky unchanged and unhurried. You are breathing history, not metaphorically, but literally, and every inhale is a conversation with the deep past. So breathe slowly now. Let the weight settle. The atmosphere holds everything: the dust of the asteroid, the first cries of creatures finding new voices, the warmth that cradled forests and the cold that would eventually come to claim them. Tonight it holds you gently and invisibly, the way it has held every living thing since the Cenozoic began. The story of the Cenozoic is not written in any book that humans composed. It is written in stone, in bone, in the chemical signatures, locked inside layers of sediment that no one was meant to read. The evidence accumulates the way snow accumulates on a field in winter, so slowly that you cannot see it happening, yet so steadily that by morning the entire landscape has changed. To understand what Earth became after the Great Silence, you must first learn to read the language of deep time, a language that does not use words, but uses pressure mineral and the patient testimony of things that died and were buried and waited millions of years for someone to dig them up and ask what happened. The first witnesses are the rocks themselves. If you could cut the earth open the way you slice a cake, you would see layers, hundreds of them, thousands of them, each one a chapter pressed flat by the weight of everything that came after. Near the bottom of the Cenozoic record, just above the thin dark line that marks the asteroid impact the rock changes, below that line you find the fossils of the Cretaceous, the teeth of mosasaurs, the bones of hadrosaurs, the shells of ammonites that had spiraled through the oceans for hundreds of millions of years. Above that line they vanish. Not gradually, not one by one, but all at once, as though someone drew a curtain across the stage and when it opened again the entire cast had been replaced. That boundary, known to geologists as the KPG boundary, is one of the sharpest lines in all of Earth's history, and it is dusted with iridium, a metal rare on Earth's surface but common in asteroids. The evidence does not whisper. It speaks clearly, and what it says is that something came from the sky and ended a world. But what interests us tonight is not the ending. It is what the rocks say about the beginning that followed. In the layers just above that dark line, the fossils are small and sparse. The creatures that appear are modest tiny mammals with teeth designed for insects, ferns that spread across scorched ground. The way weeds reclaim a vacant lot, fish that survived in rivers and shallow seas. Because water, even when the world above it burns, holds its temperature longer and forgives more easily. The evidence from these earliest Paleocene layers tells us that recovery was not instant and not dramatic. It was quiet and tentative, measured not in grand appearances, but in small presences, a jawbone here, a tooth there, a scattering of pollen grains that tells us which plants were brave enough to grow first. The Earth was not rushing to rebuild. It was feeling its way forward in the dark. As the layers climb higher and the millions of years accumulate, the evidence grows richer. Fossils become more abundant, more varied, more ambitious in their forms. You begin to find the bones of mammals that are no longer mouse-sized but dog-sized, then pig-sized, then as large as small rhinoceroses. Their teeth change too, some flattened for grinding leaves, others sharpened for tearing flesh. Still others develop the rigid surfaces of creatures learning to eat grass that does not yet exist in abundance, but will eventually cover entire continents. Each layer of rock is a snapshot, and if you flip through them quickly enough in your mind, you can almost see the animation of life expanding, testing, reaching into every available space, the way water fills a basin from the bottom, up slowly and without hesitation. The chemistry of the rocks tells its own parallel story, one invisible to the eye but profound in its implications. Isotopes of oxygen trapped in ancient shells reveal the temperature of the seas in which those shells grew. Carbon isotopes in sediment record the concentration of greenhouse gases in the atmosphere. Together, these chemical traces paint a portrait of a planet that was extraordinarily warm for millions of years. After the extinction, a greenhouse world where tropical forests extended toward the poles and the oceans held heat, like a vast planetary bath. Then, around 55 million years ago, the chemistry spikes a sudden sharp surge in carbon that scientists call the Paleocene-Eocene thermal maximum. The isotopes do not explain where the carbon came from, only that it arrived fast and in enormous quantities, and that the planet responded by warming even further, pushing temperatures to levels that would not be seen again for tens of millions of years. The evidence is precise but incomplete, like finding a letter that describes the aftermath of an event without ever naming what the event was. Pollen is another witness, humble but reliable. Fossilized pollen grains, smaller than the period at the end of this sentence, are preserved by the millions in lake sediments and ancient soils. Each grain carries the identity of the plant that produced it, and by counting and cataloguing them, layer by layer, scientists can reconstruct entire forests that no longer exist. The pollen record of the early Cenozoic tells us that palm trees grew in Alaska, that broadleaf forest flourished in Greenland, that the Arctic was not a frozen wasteland, but a warm green insect-filled woodland, where crocodiles basked on riverbanks and turtles nested in soil that never froze. This evidence is so far from our modern experience that it feels almost fictional, as though the planet is telling a story about itself that cannot possibly be true. But the pollen does not lie, and neither do the crocodile bones found at latitudes where today only polar bears dare to walk. What the evidence teaches us, layer by layer, grain by grain, isotope by isotope, is that the Cenozoic was not a single age, but a symphony of ages, each movement different in tempo and tone. The early chapters were warm, lush, and expansive, a planet draped in green from pole to pole, experimenting with new forms of life the way a musician experiments with notes after a long silence. The later chapters would bring cold, contraction, and ice, but we are not there yet. For now, the evidence asks only that you trust it, that you let the rocks speak in their slow, mineral language, and that you understand that everything we know about this age, every forest, every creature, every degree of temperature was not observed by any living witness, but was instead decoded painstakingly and beautifully from the testimony of dust. The Cenozoic left its diary in the ground, and the ground, unlike memory, does not forget. For a long time, the story of the Cenozoic seemed to make sense. The asteroid struck, the dinosaurs vanished, the mammals inherited a quiet world, and life rebuilt itself in an orderly progression from small to large, from simple to complex, from the forests of the Paleocene to the grasslands of the modern age. It was a neat story, a comforting one, the kind of narrative that fits inside a textbook and stays there without causing trouble. But science does not reward neatness for long. Eventually someone looks closer, someone measures more carefully, someone pulls a fossil from the ground that does not belong where it was found, and the clean story cracks. The Cenozoic is full of such cracks, full of anomalies, that refuse to sit quietly inside the version of a history we thought we understood. The first and perhaps the most unsettling anomaly is the speed of it all. After the extinction, mammals did not wait patiently for millions of years before diversifying. The fossil record shows that within the first few 100,000 years, a span so brief it barely registers in geological time, new species were already appearing at rates that seem almost reckless. Creatures that had spent 100 million years as small nocturnal insect-eating shadows suddenly exploded into forms that filled every vacant niche. Some grew larger within a few hundred generations. Others developed teeth and jaws suited for entirely new diets, as though evolution had been holding its breath for an eternity and now exhaled everything at once. This pace does not match the slow, gradual process that classical theory predicts. It suggests something more volatile, more opportunistic, as if life does not move at a constant speed but accelerates violently when the constraints are suddenly removed, the way water held behind a dam does not trickle forward. When the wall breaks, it floods. Then there is the anomaly of the Paleocene-Eocene thermal maximum, that sudden spike in global temperature, roughly 55 million years ago, that we touched on earlier. The evidence is unambiguous. Carbon poured into the atmosphere in quantities so vast and so rapid that the planet warmed by 5 to 8 degrees in less than 20,000 years. Oceans acidified. Species migrated thousands of miles. Some animals shrank in size as though the heat itself was pressing them smaller. But here is what unsettles the scientists who study it most closely. They cannot fully agree on where the carbon came from. Volcanic eruptions in what is now Iceland are one candidate, and there is strong evidence for massive lava flows during that period. Methane hydrates frozen on the ocean floor may have destabilized and released enormous quantities of greenhouse gas in a geological instant. Some researchers suggest that one event triggered the other, a cascade of carbon sources feeding on each other, until the atmosphere was overwhelmed. The anomaly is not that the warming happened, we can see it clearly in the isotopes, but that the trigger remains partially hidden, as though the Earth acted on a signal we have not yet learned to decode. It is like finding a room that has been rearranged in the night and knowing that something moved the furniture, but not knowing what opened the door. Another crack in the neat story involves the mammals themselves. If evolution were a simple matter of filling empty spaces, you would expect the creatures that appeared after the extinction to resemble at least roughly the ones that would eventually dominate. But many of the earliest large mammals of the Cenozoic bear almost no resemblance to anything alive today. Pantodonts, heavy, blunt-toothed herbivores the size of small rhinos, thrived for millions of years, and then vanished entirely, leaving no descendants. Creodonts ruled as the top predators across multiple continents for longer than any modern carnivore family has existed, and yet they too disappeared, replaced by the ancestors of cats and dogs that seem to have come from nowhere in particular. Winthatheras, those bizarre beasts with bony knobs on their skulls and saber-like canine teeth, despite being plant-eaters, dominated their ecosystems, and then simply stopped, as if evolution had sketched a draft, studied it for 10 million years, and then crumpled the paper and started over. The anomaly here is not extinction itself. Extinction is ordinary, but the pattern of replacement, the way entire successful lineages were erased and substituted by groups that had shown no prior sign of dominance. It raises the uncomfortable question of whether success in one age guarantees anything at all in the next. The continents add their own layer of strangeness. South America, isolated for tens of millions of years, developed a fauna so unlike the rest of the world that it might as well have been a different planet. terror birds, enormous flightless predators with crushing beaks, filled the role of apex hunters in a land where no large mammalian carnivore existed. Giant ground sloths grew to the size of elephants, armoured glyptodonts rolled across the plains like living tanks. And then, when the Isthmus of Panama rose and connected South America to the north, those unique creatures met the mammals of North America, and most of them lost. The northern species cats, dogs, bears, horses poured south and displaced lineages that had thrived in isolation for 60 million years. The anomaly is the asymmetry of it. Why did the exchange favour the north so heavily? Why did creatures perfectly adapted to their own continent crumble when the gate opened? Isolation, it seems, is both a cradle and a trap, and the Cenozoic demonstrates this with a cruelty that feels almost deliberate. Perhaps the deepest anomaly of all is the one that lives inside the climate record. The Cenozoic began in greenhouse warmth so extreme that forests grew at the poles and crocodiles swam in Arctic rivers. It ended, or rather it arrives, at its current chapter in an ice age with glaciers grinding across continents and temperatures plunging low enough to reshape every ecosystem on the planet. The transition between these two states was not smooth. It was punctuated by sudden shifts, reversals, and tipping points that suggest the climate does not change like a dial being slowly turned, but more like a switch being flipped, sometimes gently, and sometimes with a violence that leaves marks in the rock for millions of years. The anomaly is that we live inside this system right now, and the system as the Cenozoic proves beyond any reasonable doubt is capable of surprises that no model can fully predict. The cracks in the story are not flaws in our understanding. They are windows into a planet that operates on rules deeper and stranger than we have yet learned to read. There are places in the fossil record where the story simply stops, not because life ended, but because the evidence was never preserved, or was preserved, and then destroyed, or lies buried so deep beneath ocean sediment and mountain rock that no human hand has yet reached it. These gaps are not errors in the archive. They are silences, long deliberate and profound, and they remind us that for every chapter of the Cenozoic we can read, there are others that remain closed, their pages dissolved by acid groundwater or subducted into the mantle, or locked inside stone that sits beneath miles of ice at the bottom of the world. The silence in the record is not the absence of history. It is history that chose not to speak, or that spoke and was not heard, or that whispered so softly that only the most patient listeners will ever catch its meaning. Consider what it takes for a fossil to exist at all. An animal must die in the right place near water, ideally where sediment can cover the body, before scavengers and bacteria erase it entirely. The sediment must accumulate steadily, burying the remains deeper and deeper until pressure and chemistry transform bone into mineral. Then that layer must survive, not be eroded by rivers, not be melted by volcanic heat, not be folded and crushed beyond recognition by the collision of tectonic plates. And finally, millions of years later, that layer must be exposed again, pushed to the surface by uplift or erosion, and found by someone who recognizes what they are looking at. The chain of events required to produce a single readable fossil is so improbable that paleontologists sometimes say, we are not studying the history of life, we are studying the history of preservation, which is a very different thing. For every creature whose bones we hold in a museum, there are thousands, perhaps millions, that lived and died and left no trace at all. They existed as fully as any fossil species breathed the same air, walked the same ground, raised young and fled from predators, and watched the same sun cross the same sky. But the Earth did not keep their records, and so they are silent. This silence is especially deep in the oceans. The seafloor is not a permanent archive. It is a conveyor belt constantly being created at mid-ocean ridges and destroyed at subduction zones where one tectonic plate slides beneath another. The oldest ocean floor on Earth today is only about 200 million years old, which means that every inch of seafloor that existed during the early Cenozoic has long since been recycled into the mantle. Whatever fossils it carried, whatever chemical records it held, whatever stories it could have told about the temperature and chemistry and life of ancient seas, all of it is gone, melted back into the planet's interior as thoroughly as if it had never existed. We know that whales made their extraordinary transition from land to sea during this time, but the shallow coastal waters where that transformation likely occurred are among the least preserved environments in the geological record. The earliest stages of whale evolution are reconstructed from a handful of fossils found in what were once river deltas and tidal flats, environments that by sheer luck happened to preserve a few skeletons. For every transitional whale we have found, there must have been countless others, entire populations living and dying along coastlines that have since been swallowed by the sea or buried beneath kilometres of younger rock. The silence of the ocean is not empty. It is full of stories we will never hear. On land, the silence takes a different form. Tropical forests, which covered enormous stretches of the early Cenozoic world, are among the worst environments for fossil preservation. The heat, the moisture, the acidity of the soil, the relentless work of insects and fungi, all of these conspire to destroy organic material before it can be buried and preserved. A creature that dies on the floor of a tropical rainforest will be reduced to nothing within weeks, its bones dissolved, its teeth scattered, its existence erased as completely as a word written in water. This means that the very ecosystems that were most important during the warm early chapters of the Cenozoic, the vast forests that stretched from pole to pole, teeming with early primates and bizarre mammals and insects beyond counting, are the ones we know the least about. The silence of the tropical forest is the silence of abundance that left no monument of millions of years of thriving life, that vanished without a record because the conditions that made life so rich were the same conditions that made preservation nearly impossible. There are also silences that are not geological but intellectual gaps in our understanding that exist, not because the evidence is missing, but because we have not yet developed the tools or the frameworks to interpret what we have found. For decades, the early Cenozoic was treated as a footnote to the age of dinosaurs, a period of recovery before the real story of mammals began. The Paleocene in particular was neglected, its fossils understudied, its ecosystems poorly understood simply because they fell in the shadow of the more dramatic extinction that preceded them and the more charismatic megafauna that came later. Only in recent years have scientists begun to pay serious attention to these earliest chapters, and what they are finding is reshaping the story in ways that suggest the silence was never truly silent. We were simply not listening carefully enough. New fossil sites in places like Colorado, Montana and Morocco are revealing creatures that no one expected to find so early in the Cenozoic mammals that were already experimenting with size, diet and behaviour in ways that challenge the old assumption of a slow and tentative recovery. And then there is the silence that is perhaps the most haunting of all the silence of species that almost certainly existed, but that we will never find. Statistical models suggest that the fossil record captures only a tiny fraction of the species that have ever lived, perhaps as little as 1%. The rest are ghosts, real animals that ate and breathed and mated and died across millions of years of Cenozoic time, but left no physical trace that survived to the present. They are not hypothetical. They are as real as any mounted skeleton in a museum, but they exist only as absences, as empty spaces in a family tree that we fill with dotted lines and question marks. The Cenozoic is rich in what it has given us, but it is richer still in what it has withheld, and the honesty of science requires that we acknowledge both. Every confident statement about what life was like during this age is built on a foundation of silence, a vast, dark, unknowable archive of creatures and climates and landscapes that the Earth experienced but did not choose to remember. The silence is not a failure of the record. It is the record's deepest truth, a reminder that the planet does not owe us its secrets, and that what we know is always less than what was. There is an age within the Cenozoic that most people have never heard of, an age that lasted longer than the entirety of recorded human civilization multiplied 1,000 times over, and yet it sits in the popular imagination, like a room in a house that no one visits, furnished inhabited once, but now gathering dust behind a door that is rarely opened. This is the Paleocene, the first epoch of the Cenozoic stretching, from 66 million years ago to roughly 56 million years ago, and it is the forgotten epoch, not because it was uneventful, but because it was overshadowed on both sides by events so dramatic that the quiet work it did in between has been largely ignored. Before it stands the extinction, the asteroid, the fire, The death of the dinosaurs were one of the most cinematic moments in all of Earth's history. After it comes the Eocene with its extreme heat, its evolutionary explosions, its whales learning to swim, and primates learning to climb. The Paleocene sits between these two spectacles, like a person standing between two bonfires invisible, not because they are not there, but because the light on either side is too bright to see past. But the Paleocene was not quiet. It was in many ways the most important 10 million years of the entire Cenozoic, because it was the age in which the rules of the New World were written. Everything that followed the rise of grasslands, the diversification of whales, the emergence of primates, the eventual appearance of humans, all of it depended on what happened in this forgotten window, when the survivors of the extinction looked around at an empty world and began slowly and without any guarantee of success to figure out what to do with it. The Paleocene was not a pause between acts. It was the act in which the foundations were laid, the one that determined what kind of story the Cenozoic would become, and the fact that it is so rarely discussed tells us something important about how we choose which chapters of history to remember and which ones we allow to fade into silence. The world of the Paleocene was warm and wet and green in ways that are difficult to overstate. Without ice at the poles, without the sharp seasonal contrasts that define our modern climate, the planet existed in a state of perpetual mildness that allowed forests to grow almost everywhere. These were not the forests, not the pine stands of the north or the deciduous woodlands of the temperate zones, but dense, humid, layered canopies of broadleaf trees and palms that stretched across continents without interruption. In what is now Wyoming, fossil beds reveal forests of magnolias and sycamores growing alongside palms and ferns, ecosystems that look more like modern-day Southeast Asia than anything you would associate with the American West. In Greenland, forests of dawn redwood and metasequoia grew in soil that today lies buried under ice, their leaves falling into lakes that preserved them so perfectly that you can still see the veins in each fossil leaf, as though the tree only just let go of it. The Paleocene forest was not a single biome, but a vast green quilt draped across the planet, varied in its details but unified in its warmth and its relentless, almost suffocating abundance. Inside these forests, the mammals of the Paleocene were conducting the earliest experiments in what it meant to be large, to be predatory, to be herbivorous, to be anything other than the small nocturnal survivors they had been for 100 million years. Pantodonts were among the first to grow truly large, heavy-bodied, slow-moving creatures with blunt teeth and thick limbs that browsed on soft vegetation, the way a modern tapir might, though they were related to nothing alive today. They were not elegant and they were not fast, but they were pioneers, the first mammals to occupy the large herbivore niche that the dinosaurs had vacated, and for several million years they were among the biggest animals on land. Alongside them moved creodonts, the dominant predators of the age animals that look superficially like wolves or hyenas, but belong to a lineage entirely their own. Their teeth were built for slicing flesh, their jaws powerful enough to crack bone, and they hunted the pantodonts and other herbivores through forests so thick that ambush was the only viable strategy. Neither pantodonts nor creodonts would survive the Cenozoic. Both lineages eventually went extinct, replaced by newer, more efficient forms, but in the Paleocene they were the rulers, the first draft of a world that would be rewritten many times. The smallest creatures of the Paleocene are in some ways the most significant because among them were the earliest primates. These were not monkeys or apes, they were tiny wide-eyed nocturnal animals that clung to branches with grasping hands and feet, hunted insects in the dark and navigated the canopy with a precision that their forward-facing eyes made possible. They weighed less than a modern squirrel, and if you saw one today you might mistake it for a lemur or a tarsier, creatures that are themselves living echoes of this ancient design. The Paleocene primates did not know that they were the beginning of a lineage that would one day produce language, art, mathematics, and the ability to look back across 66 million years and wonder how it all started. They simply lived gripping bark with their small fingers, listening for the rustle of beetles in the leaf litter below, breathing the thick, humid air of a world that belonged entirely to the forest. The oceans of the Paleocene carried their own forgotten stories. Sharks, which had survived the extinction with the same quiet stubbornness that had carried them through every previous catastrophe, diversified into new forms and reclaimed the upper tiers of the marine food chain. Bony fish radiated into hundreds of new species filling coral reefs that were themselves rebuilding after the collapse of the Cretaceous. And along the coasts, in the warm, shallow waters where rivers met the sea, small hoofed mammals were beginning to wade cautiously at first, then with increasing confidence, into an environment that would eventually transform their descendants into whales. The Paleocene ocean was a nursery for futures that no one could have predicted, a place where the boundaries between land and sea were soft and permeable, and where the creatures that crossed them did so without any awareness that they were making choices that would echo for millions of years. What makes the Paleocene a forgotten epoch is not that it lacked drama, but that its drama was internal, structural, foundational, the kind of work that happens beneath the surface, and is only recognised long after the fact. It was the age in which the blueprints were drawn, the age in which the survivors tested every possible strategy, and the Earth decided through the slow referendum of natural selection which experiments would be allowed to continue and which would be quietly shelved. The Paleocene does not appear in popular documentaries because its animals are unfamiliar, and its events lack the spectacle of asteroid impacts or ice ages. But without it, nothing that followed would have been possible. It is the root system beneath the tree, the foundation beneath the cathedral, the silence before the symphony begins to play. Every mammal that walks the earth today, every whale that breaches every primate that reaches for a branch carries inside it the inheritance of those 10 million forgotten years, when the world was warm and green and uncertain, and life was learning one small step at a time how to begin again. We tell ourselves that catastrophe is the enemy of life, that destruction is the opposite of creation, that when the world breaks it must be repaired before anything good can happen again. But the Cenozoic tells a different story, one in which catastrophe is not the enemy, but the editor, not the end of the sentence, but the breath between paragraphs, the moment when the earth pauses, exhales, and begins again with a different vocabulary. The asteroid that ended the Cretaceous was not a punishment inflicted on a planet that had done something wrong. It was a reset, and the Cenozoic that followed was not a recovery from disaster, but a response to opportunity. The distinction matters because it changes how we understand not only the past, but the nature of change itself. The Earth does not break, it adjusts. And its adjustments, though they may look like endings from the inside, are always without exception also beginnings. The reset at the start of the Cenozoic was total in a way that is almost impossible to comprehend from a human perspective. Within a geological instant, weeks, perhaps months, the dominant life forms on land, sea and sky were gone. Not diminished, not reduced, but erased. The ecosystems that had been built over 100 million years of careful evolutionary negotiation collapsed as completely as a house of cards in a sudden wind. Food chains that had linked the smallest plankton to the largest sauropods snapped at every link. Forests burned across continents. The oceans darkened as photosynthesis stalled, and the base of the marine food web dissolved. For a period that may have lasted years, the planet existed in a state of suspended animation, not dead, but not functioning in any way that resembled what had come before. The reset was not gentle, it was absolute, indiscriminate, and merciless in its thoroughness. And yet within that mercilessness lay something that can only be described as generosity, because the very completeness of the destruction was what made the rebuilding so extraordinary. When the dust settled, literally, as the particulate matter from the impact slowly cleared from the atmosphere over months and years, what remained was a planet stripped of its dominant players, but still rich in the raw materials of life. The soil was still there, enriched in some places by the ash and organic matter of the destruction. The ocean still held water, still circulated, still carried nutrients. The atmosphere, though, altered in its chemistry, still held oxygen, still trapped. Warmth still moved in the great convective patterns that drive weather and wind. The stage had been cleared, but the stage itself was intact, and the survivors, the small mammals in their burrows, the birds descended from feathered dinosaurs, the crocodiles and turtles that had weathered the storm in rivers and swamps, the sharks that had simply continued swimming, found themselves in a world that was not ruined but emptied. The difference between those two conditions is everything. A ruined world offers nothing. An emptied world offers everything to anyone bold enough or fortunate enough to step into the open space and claim it. The Cenozoic is proof that life does not merely tolerate resets, it requires them. Without the extinction of the dinosaurs, mammals would almost certainly have remained small nocturnal marginal creatures indefinitely. The ecological dominance of the great reptiles was so complete, so deeply entrenched that no amount of gradual evolution could have dislodged them. It took an external shock of almost inconceivable violence to open the door, and once that door was open, mammals poured through it, with a speed and creativity that suggests they had been ready all along, pressed against the threshold for 100 million years waiting for a chance that geology and chance finally provided. The reset did not create mammals, they had existed for as long as the dinosaurs themselves, but it created the conditions under which their potential could finally be expressed. In that sense, the asteroid was not the destroyer of a world, but the liberator of one that had been waiting inside the old world all along, compressed and patient and invisible. This pattern destruction, followed not by decline but by explosive reinvention, is not unique to the start of the Cenozoic. It repeats throughout the era at smaller scales, but with the same underlying logic. The Paleocene, Eocene, thermal. Maximum that sudden spike in temperature 55 million years ago disrupted ecosystems across the planet and drove many species to extinction, or forced them into rapid adaptation. But it also triggered one of the greatest bursts of mammalian diversification in history, scattering new species across continents as warmth opened corridors and created habitats that had not existed before. Millions of years later, the cooling that began in the Oligocene shrank forests and replaced them with grasslands, a transformation that devastated the tree-dwelling creatures that had thrived in the warmth, but simultaneously created an entirely new world for grazers runners and the predators that hunted them. Horses evolved their hooves on those grasslands, antelope evolved their speed, wolves evolved their stamina and their packs. Every one of these adaptations was born not from comfort, but from crisis, not from stability, but from the disruption of stability. The ice ages of the Pleistocene repeated the pattern on an even grander scale. Glaciers advanced, grinding across continents, destroying forests, displacing entire ecosystems southward, and killing everything that could not move or adapt. Then, they retreated, and in the newly exposed land, life surged forward again, different from before, reshaped by the pressure, but no less abundant and no less creative. The megafauna of the Ice Ages, mammoths, woolly rhinos, giant sloths, saber-toothed cats were products of the reset creatures forged by the demands of a world in constant flux, and their eventual disappearance at the end of the last glacial period was itself another reset one that cleared the way for the ecosystems and the human civilizations that followed. Each cycle of destruction and renewal left the world changed, but not diminished, different, but not lesser, as though the planet were a musician playing the same melody in an endless series of variations, each one shaped by the silences between the notes. What the Cenozoic teaches us about resets is both humbling and consoling. It is humbling because it shows that no dominance is permanent, that no creature, no matter how powerful or well adapted, is immune to the forces that reshape the world. The dinosaurs ruled for 160 million years, and they fell in an afternoon. The creodonts dominated for tens of millions of years, and they were replaced by carnivores that had once been insignificant. The great forests of the Eocene covered the planet, and they retreated before the advance of grass. Nothing endures unchanged, and the Cenozoic is a 66 million year demonstration of that truth. But it is consoling because it also shows that endings are not final, that what looks like destruction from the inside is often creation when viewed from a sufficient distance. The Earth does not mourn its resets, it uses them. It treats each catastrophe not as a wound, but as a draft, a sketch to be revised, an old arrangement to be reconsidered and improved upon. The reset is not the opposite of life. It is the mechanism by which life renews itself, the exhale that makes the next inhale possible, the silence that gives the next sound its meaning. The Cenozoic began with the deepest reset the planet had experienced in 66 million years. And from that reset came everything, every forest, every ocean current, every mammal, every bird, every human being alive today. We are not survivors of catastrophe. We are its children. The past does not stay where we leave it. We imagine deep time as something sealed behind glass, visible but untouchable, a sequence of events that ended long before we arrived, and has no bearing on the warmth of our beds or the rhythm of our breathing tonight. But the Cenozoic did not end. It continues not as a memory but as a presence woven so deeply into the fabric of the present that we carry it without knowing the way a river carries the shape of mountains it left behind 1,000 miles ago. The echoes of the age are not metaphors. They are physical, measurable, alive in the architecture of your body, in the chemistry of the air you breathe, in the behaviour of every creature you have ever watched. Move across the ground or fly across the sky. The past vibrates in the present the way a bell vibrates long after it has been struck. And if you learn to listen, you can hear the Cenozoic ringing in everything. Begin with your own hands. Spread your fingers and look at them the way each one moves independently, the way the thumb opposes the others, the way the grip can shift from power to precision in an instant. Those hands were designed in the Paleocene 60 million years ago, when tiny primates no bigger than squirrels clung to branches in tropical forests that stretched across a world without ice. The grasping hand was not invented for writing or painting or building. It was invented for holding onto bark in the dark, for catching insects between finger and thumb, for navigating a three-dimensional world of branches where a missed grip meant death. Every time you pick up a cup, turn a key, or hold another person's hand, you are using a tool that was engineered by the forests of the early Cenozoic and refined across tens of millions of years of climbing, reaching and holding on. Your hands are echoes of trees that no longer exist, shaped by a world that vanished long before the first stone tool was ever struck. Your eyes carry an even older echo, the forward-facing vision that allows you to judge distance, to perceive depth, to catch a ball or thread a needle. That arrangement was not designed for any human purpose. It was designed for leaping between branches in low light, for judging the distance between one handhold and the next, in a canopy where miscalculation meant falling to the forest floor. The colour vision that lets you distinguish ripe fruit from unripe, red from green. Warm tones from cool that was a gift from the Eocene, when primates that could see the ripest fruit in a sea of green leaves had a survival advantage over those that could not. You do not see the world the way you do because human engineers designed your eyes. You see it this way because Eocene forests selected for it, and the selection was so successful that 50 million years later, you still carry the result, using it to read screens and admire sunsets and recognize the faces of people you love, none of which the original design anticipated, but all of which it makes possible. The echoes extend far beyond the human body. The horses that graze in modern pastures carry in their single hooves the memory of a 50 million year transformation from soft-footed forest browsers to hard-hooved plains, runners each generation's feet adapting to ground that was slowly changing from forest floor to grassland soil. The whales that sing in the deep ocean carry in their vestigial pelvic bones the memory of legs that once walked on land of ancestors that waded into rivers and shallow seas and never came back. Elephants carry in their massive grinding teeth the echo of a world that shifted from soft leaves to tough grasses, demanding new machinery for chewing that changed the shape of their skulls and the rhythm of their lives. Every living animal is a museum of the Cenozoic, its body a collection of adaptations accumulated across millions of years, each one a response to a world that no longer exists, but whose influence persists in bone and muscle and instinct. Even the landscapes carry echoes. The Great Lakes of North America are not natural features in the way that oceans or rivers are. They are scars left by glaciers that advanced and retreated during the Pleistocene ice ages, grinding basins into the bedrock and then filling them with meltwater as the ice withdrew. The fjords of Norway are echoes of the same process, valleys carved by rivers of ice that have since vanished, leaving behind corridors of deep water, flanked by cliffs that remember the weight that shaped them. The fertile soils of the American Midwest, the breadbasket of a modern nation, are composed of loess, fine dust blown by glacial winds tens of thousands of years ago, and deposited in layers that now grow wheat and corn. The very ground that feeds the modern world is an echo of the ice ages, a gift from a climate that no longer exists, but whose generosity continues to sustain billions of lives. The atmosphere itself is an echo chamber. The oxygen you breathe tonight was produced by photosynthesis by forests and plankton, that have been cycling carbon and oxygen for the entire duration of the Cenozoic. The balance of gases in the air is not a static condition, but a living equilibrium maintained by 66 million years of biological and geological processes, each one adjusting the chemistry slightly, each one contributing to the particular mixture that fills your lungs at this very moment. The carbon dioxide that now concerns climate scientists is itself an echo, some of it released from fossil fuels that were once living plants in Cenozoic swamps, their carbon locked away for tens of millions of years, and now return to the atmosphere in a geological instant, as though the past were insisting on being heard whether we wanted to listen or not. The deepest echo of all may be behavioural, the social bonds that hold human communities together, the instinct to protect children, to cooperate with strangers, to form alliances and mourn the dead. These are not inventions of civilization. They are echoes of primate societies that began forming in the Eocene and grew more complex across the Oligocene and Miocene, refined by millions of years of living in groups where survival depended on trust and communication. When you feel the pull of loyalty to a friend, the grief of losing someone close, or the comfort of simply sitting near another person in silence, you are feeling the echo of a social architecture that was built in the trees of ancient Africa, long before the first human walked upright on the savanna below. The Cenozoic did not merely produce the world we live in. It produced us our hands, our eyes, our instincts, our bonds, and we carry it forward whether we know it or not, one echo at a time. We are taught to think of history as a line, a single thread stretching from the past to the present, from primitive to advanced, from simple to complex, each generation building on the one before, in an unbroken march towards something better. It is a comforting story because it implies direction, purpose, a destination that justifies the journey. But the Cenozoic does not tell that story. The Cenozoic tells a story of circles of rhythms, of patterns that repeat with variations so subtle that you might not recognize them unless you step far enough back to see the whole arc at once. And when you do step back, when you compress 66 million years into a single view, what emerges is not a line but a pulse, a heartbeat, a planet breathing in and breathing out, across timescales so vast that each individual breath contains entire civilizations of creatures that lived and died without ever knowing they were part of a cycle. The first pattern is thermal, the long oscillation between greenhouse and icehouse that defines the Cenozoic like a tide defines a shore. The era opened in extraordinary warmth, a planet without ice, where forests stretched to the poles and the air hung heavy with carbon dioxide and moisture. That warmth held for millions of years, peaking in the Eocene, when crocodiles basked in Arctic rivers and palm trees grew where glaciers now grind. Then slowly and unevenly but unmistakably the warmth receded. Temperatures fell across the Oligocene as Antarctica froze and ocean currents reorganized. The Miocene brought partial recovery warm intervals that let forests spread again and apes diversify across 3 continents, but the long trend continued downward. By the Pliocene, ice had claimed both poles. By the Pleistocene, glaciers were advancing and retreating across the northern hemisphere in cycles so regular they could almost be predicted. Warmth, then cold, then warmth again, the pattern repeating not once but dozens of times each cycle, reshaping ecosystems, driving extinctions and forcing survivors to adapt or move. The planet was not marching toward cold. It was oscillating, swinging between states the way a pendulum swings between extremes, never settling permanently on either side. The second pattern is biological, the rise, diversification, and eventual replacement of dominant groups in a sequence that repeats with almost musical regularity. In the Paleocene, pantodonts and creodonts ruled the first large herbivores and carnivores of the mammalian age. They thrived for millions of years and then faded, replaced by newer lineages that were faster, more efficient, or simply luckier in the lottery of environmental change. Horses began as tiny forest browsers and transformed into plains runners, their form shifting with each climatic swing. Whales began as small land-dwelling creatures and became the largest animals ever to live, their bodies reshaped so completely that only their bones remember where they started. Apes diversified into dozens of species across the Miocene, then contracted to a handful as forests shrank, and from that handful came the lineage that would eventually produce humans. In every case, the pattern is the same: expansion during favourable conditions, contraction during stress replacement of the old by the new, and then the cycle beginning again with different players but the same underlying rhythm. No group dominates forever. No adaptation is permanent. The wheel turns, and what rises must eventually make room for what comes next. The third pattern is geographical, the way continents drift, collide, and separate in cycles that reshape the planet's surface and redirect the flow of life. During the Cenozoic, India collided with Asia and raised the Himalayas, a process that altered monsoons, drew down atmospheric carbon, and helped push the planet toward its current icehouse state. South America drifted in isolation for tens of millions of years, developing unique fauna that flourished in the absence of competition, then reconnected with North America through the Isthmus of Panama, and watched as northern species poured south and displaced many of the creatures that isolation had nurtured. Australia separated from Antarctica and carried its marsupials into a long, evolutionary experiment that produced kangaroos, wombats, and predators unlike anything on any other continent. Each continental movement created new conditions, new barriers, new corridors for migration, and life responded to each one with the same pattern. Isolation breeds uniqueness. Connection breeds competition, and the outcome is always a reshuffling of the deck, never a permanent arrangement. What makes these patterns significant is not their individual details, but their convergence, the way thermal, biological, and geographical cycles interlock and reinforce each other, like gears in a machine so large that no single creature living inside it can perceive its shape. When the climate cools, forests retreat, and forest-dwelling species contract while grassland species expand. When continents collide, mountains rise, weather patterns shift, and the biological communities on either side of the new barrier begin to diverge. When ocean currents reorganize, nutrient distributions change, and the marine food web restructures itself from the plankton up. Each cycle influences every other, and the result is not chaos, but a kind of order, complex, layered and repetitive in its deep structure, even as its surface details change with every iteration. The Cenozoic is not random. It is patterned, and its patterns are written in the same language of expansion and contraction, rise and fall that governs everything from the beating of your heart to the orbiting of planets around stars. The recognition of pattern changes how we understand our own place in the story. If history is a line, then we stand at its leading edge, the most advanced point, the culmination of everything that came before. But if history is a circle, or rather a spiral, repeating its themes at ever-shifting scales, then we are not the destination. We are one turn of the wheel, one iteration of a pattern that has played out before and will play out again. The mammals that rose after the dinosaurs fell were not the first group to inherit a devastated world, and they will not be the last. The forests that spread across the Eocene were not the first to cover the planet, and the grasslands that replaced them were not the first open landscapes to host great herds. The ice that carved the Pleistocene was not the first ice age in Earth's history, and the warming that ended it was not the first thaw. Everything that seems new has happened before in some form, and everything that seems permanent is only the current expression of a cycle that will eventually turn again. The pattern does not care about the names we give to its phases. It simply continues, patient and vast, carrying everything: forests, oceans, species, civilizations on its slow rotation through deep time. Tonight, as you breathe in the dark, you are part of that pattern. One breath among billions. One turn of a wheel that has been spinning for 66 million years and shows no sign of stopping. The Earth has never been silent before a catastrophe. It has always spoken, not in words, not in sirens, not in anything so convenient as a message addressed to the creatures living on its surface, but in shifts so slow and signals so subtle that only the rock remembers them afterward. The Cenozoic is full of warnings, moments when the planet changed its tone, the way a symphony changes key before a climax, and the creatures living through those moments had no way of knowing what the shift meant, because the language of geological warning operates on timescales that no single life can perceive. A warning that takes 10,000 years to deliver is not a warning to a creature that lives for 30. It is background noise, a slight change in the colour of the sky that no one thinks to mention because no one alive remembers when the sky was different. And yet the warnings were there, written into the chemistry of the oceans, the retreat of coastlines, the slow migration of forests, the quiet disappearance of species that had once been common. The Earth always tells you what is coming. The tragedy is that it tells you in a language you are not designed to understand. The first great warning of the Cenozoic came before the Paleocene-Eocene thermal maximum, that sudden spike in temperature 55 million years ago that we have already visited. In the layers of sediment just below the event, scientists have found evidence of smaller carbon releases, preliminary pulses, that preceded the main surge like tremors before an earthquake. The ocean chemistry shifted slightly. Certain species of foraminifera, tiny-shelled organisms that are exquisitely sensitive to changes in water temperature and acidity, began to decline in numbers and diversity. The signal was faint, buried in data that would not be read for another 55 million years. But it was there a whisper in the sediment that said, something was building. Something was destabilizing. Something beneath the surface was preparing to release. When the full thermal maximum arrived, it came fast, but it did not come without precedent. The Earth had been clearing its throat for thousands of years before it finally spoke, and the creatures living through those preliminary shifts had no framework for interpreting what the changes meant. They simply experienced a world that was growing slightly warmer, slightly different, and they adjusted as best they could until adjustment was no longer sufficient. The cooling that began in the Oligocene carried its own set of warnings, though they unfolded over millions of years rather than thousands. As Antarctica separated from South America, and the circumpolar current locked the southern continent into isolation, the planet's heat distribution began to change. Forests that had stretched toward the poles for tens of millions of years started to thin their edges, retreating toward the equator so slowly that no generation of creatures would have noticed the boundary shifting. But the pollen record captures it grain by grain, layer by layer. The tropical species giving way to temperate ones, the temperate ones giving way to grassland indicators, the grassland spreading into regions that had known only trees for as long as life had occupied them. The warning was written in pollen in the slow replacement of one community by another, and it told a story of a planet that was losing its warmth, not suddenly but steadily, like a house where someone has turned the thermostat down by 1 degree every century. By the time the change was obvious, by the time glaciers appeared and ice sheets spread, and entire biomes had reorganized, the warning had been broadcasting for millions of years to an audience that could not hear it. The Pleistocene ice ages brought warnings of a different kind, shorter and sharper, embedded in the cycles of advance and retreat that defined the epoch. Before each major glacial expansion patterns in ocean sediment show shifts in the ratio of oxygen isotopes, a signal that water was being locked into ice somewhere, that sea levels were beginning to drop, that the planet was tipping toward cold. Before each interglacial warming, the same isotopes shifted back, recording the release of meltwater and the return of warmth. These cycles repeated dozens of times, and each transition carried its own suite of signals, changes in dust deposition, as winds strengthened over drying landscapes, shifts in pollen, as vegetation zones migrated, alterations in the chemistry of cave formations, as rainfall patterns changed overhead. The warnings were precise and legible in hindsight, but they operated on timescales of centuries to millennia, visible only to a science that would not exist for tens of thousands of years after the events they recorded. The animals of the Pleistocene, the mammoths and mastodons, the saber-toothed cats and giant sloths, lived and died within these warnings, without ever perceiving them as such, adapting to changes they experienced as simply the way the world was. The most recent warning is the one we are living inside right now, and it is perhaps the strangest of all, because for the first time in the Cenozoic, the species receiving the warning is also the species causing the change. The carbon dioxide that is accumulating in our atmosphere is not coming from volcanic eruptions or destabilized methane hydrates. It is coming from us from the burning of fossil fuels that were themselves products of Cenozoic forests and swamps, ancient carbon locked away for tens of millions of years and now released in a geological instant. The ocean chemistry is shifting in ways that mirror the early stages of the Paleocene. Eocene thermal maximum acidification, increasing carbonate saturation, decreasing the same for foraminifera that declined 55 million years ago, showing stress in modern waters. Ice cores from Greenland and Antarctica record the current rise in carbon dioxide as a spike so sharp and so sudden that it stands out from the surrounding record like a shout in a quiet room. The Earth is not whispering this time. It is speaking clearly in a language that our instruments can read and our minds can interpret, and yet the response remains uncertain because understanding a warning and acting on it are two very different things. The Cenozoic teaches us that warnings are never absent, they are only unread. Every great transition in the era was preceded by signals that with sufficient knowledge and sufficient distance can be decoded from the geological record. The planet does not ambush its inhabitants. It announces its intentions through chemistry, through biology, through the slow rearrangement of systems that are too large and too gradual for any single generation to perceive as urgent. The question has never been whether the Earth warns us. It always does. The question is whether we are capable of hearing what it says and wise enough to act before the transition is complete. The Cenozoic is full of creatures that received warnings and could not understand them. Creatures that adapted too slowly or moved too late or simply did not have the capacity to read the signals written in the sediment beneath their feet. We are the first species in 66 million years that can read those signals. What we do with that ability is the one part of the story that has not yet been written. There is a conversation happening between the sky and the ground beneath you, and it has been happening for longer than any living thing can remember. It is not a conversation in words or sounds, but in forces, gravity pulling downward heat, radiating upward, light arriving from a star 93 million miles away and striking rock that has been waiting for it since before the continents had names. The Cenozoic, like every age before, it was shaped not only by what happened on the surface of the Earth, but by what happened above it in the tilt of the planet's axis, in the wobble of its orbit, in the slow gravitational negotiations between Earth and Moon and Sun that determine how much energy reaches which latitude at which time of year. The sky is not a backdrop to the story of life. It is a co-author, and its influence runs through every chapter of the Cenozoic, like a thread that holds the pages together even when the narrative seems to change direction entirely. The most direct connection between sky and Earth during the Cenozoic is sunlight, the raw energy that drives photosynthesis, warms the oceans, melts the ice, and sustains every food chain on the planet. But sunlight does not arrive in constant quantities. The Earth's orbit around the Sun is not a perfect circle, but an ellipse that shifts its shape over cycles of roughly 100,000 years, sometimes bringing the planet slightly closer to the Sun, sometimes pulling it slightly farther away. The tilt of the Earth's axis, the angle that gives us seasons, wobbles between about 22 and 24.5 degrees over a cycle of roughly 41,000 years. And the axis itself processes spinning slowly like a top winding down, completing a full rotation every 26,000 years. These three cycles, named for the Serbian mathematician Milutin Milankovic, who first calculated their effects, interact in patterns so complex that their combined influence on climate is never exactly the same twice. Yet their cumulative effect is profound. They are the metronome of the ice ages, the invisible hand that pushed glaciers forward and pulled them back across the Pleistocene, the sky reaching down to sculpt the surface of the Earth with nothing more than the angle at which light falls. The relationship between sky and Earth is not one-directional. The surface of the planet talks back. When ice sheets expand, they reflect more sunlight into space, cooling the atmosphere further and encouraging more ice to grow a feedback loop, in which the ground amplifies a signal that originated in the sky. When forests spread their dark canopies, absorb more sunlight than bare soil, or ice wood warming the surface and influencing atmospheric circulation. When volcanoes erupt, they inject sulfur dioxide into the stratosphere, where it forms aerosols that reflect sunlight and can cool the planet for years. The eruption of massive volcanic provinces during the early Cenozoic fields of lava in what is now the North Atlantic may have contributed to the carbon releases that triggered the Paleocene-Eocene thermal maximum, a case in which the Earth's interior reached up through the crust and altered the composition of the sky, which in turn altered the temperature of the surface, which in turn altered the course of evolution for millions of years. The conversation between sky and Earth is not a monologue delivered from above. It is a dialogue, each participant responding to the other, in a feedback loop so intricate that separating cause from effect becomes almost impossible. The stars too play their part, though their influence is more distant and more difficult to measure. The Sun is not a fixed lamp, but a variable star whose energy output fluctuates in cycles of roughly 11 years, and over longer time scales its luminosity has slowly increased since the formation of the solar system. Over the course of the Cenozoic, that increase has been tiny, negligible on human timescales, but across 66 million years, even small changes in solar output interact with atmospheric composition and orbital mechanics to nudge the climate in directions that would not have occurred otherwise. Beyond the Sun, the solar system itself moves through the galaxy, passing through regions of higher and lower cosmic ray flux, which some researchers have suggested may influence cloud formation and thereby climate, though this hypothesis remains debated. What is not debated is that Earth is not an isolated system. It is embedded in a cosmic environment, and the energy it receives from that environment is the fundamental driver of everything that happens on its surface, from the growth of a fern, to the advance of a glacier, to the evolution of a species capable of looking upward and wondering what the stars have to do with the mud beneath its feet. The mountains that rose during the Cenozoic, the Himalayas, the Andes, the Alps, the Rockies, are themselves products of the conversation between deep Earth and open sky. Tectonic forces pushed them upward, but once they stood above the surface, they became participants in atmospheric circulation, redirecting winds, capturing moisture, creating rain shadows that turned lush regions into deserts, and funneling precipitation into rivers that carved valleys and deposited fertile sediment across plains. The Himalayas did not merely change the geography of Asia, they changed the sky above it, strengthening the monsoons that bring rain to billions of people today, and they changed the chemistry of the atmosphere by exposing fresh rock to weathering that draws carbon dioxide out of the air and locks it into sediment washed down to the sea. A mountain is not just stone, it is a conversation between the interior of the planet and the atmosphere above it, a place where Earth literally touches sky, and where the interaction between the two reshapes everything: climate, rivers, ecosystems, the course of evolution itself. Perhaps the most profound connection between sky and Earth during the Cenozoic is the one we rarely think about, the simple fact that the atmosphere is not separate from the biosphere but a product of it. The oxygen you breathe was not placed in the sky by geology. It was placed there by life, by billions of years of photosynthesis that transformed a suffocating early atmosphere into one that could support the metabolism of mammals, birds, and eventually humans. The forests of the Cenozoic were not merely inhabitants of the surface, they were architects of the sky, pulling carbon from the air and releasing oxygen, regulating the greenhouse effect influencing cloud formation through the release of volatile organic compounds that seed water droplets. The grass that spread across the Miocene plains, the plankton that bloomed in cooling oceans, the algae that clung to rocks in shallow seas, all of them were participants in the construction of the atmosphere, building the sky from below the way the sky shaped them from above. The conversation has no beginning and no end. It is continuous, reciprocal, and so deeply woven into the fabric of the planet that you cannot understand the history of life without understanding the history of the air above it, or the light that feeds it, or the orbital mechanics that determine how that light is distributed across a spinning, tilted, wobbling world suspended in the dark between stars. Tonight the sky above you is the same sky that watched the Cenozoic unfold, older than any forest, deeper than any ocean patient beyond comprehension, and the ground beneath you is still answering it, still speaking in the slow language of rock and root, and river still carrying on a conversation that began before the dinosaurs fell and will continue long after the last echo of the Cenozoic has faded into whatever comes next. There is a feeling you have sometimes standing in a place you have never been before, where something in the light or the angle of the land or the way the wind moves through the grass makes you pause and think, I have been here. Not literally, not in this life, not in any memory you can name, but somewhere deeper than memory, in a place inside your body that recognizes the shape of the world before your mind does. That feeling is not an illusion. It is a return not to a specific place or a specific time, but to a pattern so old and so deeply embedded in the architecture of living things that it surfaces without permission, the way a melody you heard as a child can rise unbidden when the air smells a certain way, or the evening light falls at a certain angle. The Cenozoic is full of returns moments when the planet circles back to something it has done before, not identically but recognisably, the way a river that has been diverted by a landslide will eventually find its way back to something resembling its original course. Nothing in deep time is truly new. Everything is a variation on a theme that the Earth has been playing since long before the first mammal opened its eyes in the dark. The most visible return is the one written in ice. The Cenozoic began without ice, a greenhouse world where warmth reached the poles and forests grew on every continent without interruption. Then, over tens of millions of years, the planet cooled, and ice appeared first on Antarctica, then in the northern hemisphere, advancing and retreating in cycles that lasted tens of thousands of years each. But this was not the first time Earth had frozen. Long before the Cenozoic, long before the dinosaurs, the planet had experienced ice ages so severe that glaciers may have reached nearly to the equator, the so-called snowball Earth events of the Proterozoic, more than 600 million years ago. The Cenozoic ice ages were gentler by comparison, but they followed the same fundamental pattern, a planet cooling ice, expanding life contracting toward the equator, and then warmth, returning ice, retreating life spreading outward again. The return of ice in the Cenozoic was not an anomaly, it was a repetition, a planet revisiting a state it had known before, the way a sleeper returns to the same position night after night, without choosing to guide it by the shape of the body and the pull of gravity. The return of grasslands follows a similar logic. When grass is spread across the continents during the Miocene, replacing forests that had dominated for tens of millions of years, it seemed like something new, a biome that had never existed before, creating ecosystems unlike anything the world had seen. But open landscapes had existed before the Cenozoic, and the ecological dynamics of grazers and predators on open plains were not invented by the Miocene but rediscovered the same relationships between speed and endurance, between herd and hunter, that had played out in different forms during earlier geological periods when the world's vegetation was shaped by different climates and different players. The horses that evolved to run across Miocene grasslands were not the first animals to develop speed as a survival strategy on open ground. They were the latest iteration of a design that evolution returns to whenever the landscape opens up and the trees fall back. The return is not exact. The species are different. The chemistry of the grasses is different. The specific predators are different. But the underlying architecture, the open plain, the herd in motion, the predator in pursuit is a pattern the Earth has built before, and will build again whenever conditions permit. Even the rise of intelligence follows a pattern of return. We tend to think of human intelligence as unprecedented, a singular event in the history of life, and in its specific form it is. No other species has built cities or written symphonies or looked back across 66 million years and tried to reconstruct what happened. But the general trend toward larger brains, more complex social structures and greater behavioral flexibility is not unique to the human lineage. It has appeared independently in multiple groups during the Cenozoic in dolphins, whose brains grew large and whose social networks grew intricate in the oceans, in elephants whose memory and emotional depth rival anything in the primate world, in crows and parrots whose problem-solving abilities suggest a kind of intelligence that evolved entirely separately from the mammalian version. The return of intelligence, or rather the repeated emergence of intelligence in different lineages under different conditions, suggests that it is not an accident, but a tendency, a solution, that evolution finds again and again when the conditions are right, the way water finds the lowest point in a landscape, not because it is directed there, but because the shape of the ground makes that outcome almost inevitable. The cycles of extinction and recovery are themselves returns. The Cenozoic began with the recovery from one of the 5 great mass extinctions in Earth's history, and that recovery followed a pattern that had been established by earlier catastrophes, the rapid expansion of survivors into vacant niches, the experimental diversification of new forms, the eventual stabilization into mature ecosystems that would persist until the next disruption. The Ordovician extinction, the Devonian extinction, the Permian extinction, the Triassic extinction. Each one was followed by a recovery that looked different in its details but identical in its structure. Life contracts. Life waits, life expands again, filling the emptied spaces with new variations on old themes. The Cenozoic recovery was the latest in a series stretching back nearly 500 million years, and there is no reason to think it will be the last. The pattern returns because the conditions that produce it return: catastrophe, vacancy, opportunity, adaptation. And because life itself is not a fragile experiment, but a stubborn, resilient process that has survived every test the planet has thrown at it, and emerged each time not diminished but transformed. The deepest return of all is the one you are living through right now, though you may not recognize it as such. The Holocene, the warm interglacial period that has lasted for the past 12,000 years, and given humanity the stable climate it needed to build. Agriculture, cities, and civilization is not a permanent state. It is a pause in a cycle, a warm breath between glacial advances that have been repeating for more than 2 million years. The ice will return. Not tomorrow, not in a century perhaps, not for thousands of years, but the orbital mechanics that drive the glacial cycles have not stopped, and the pattern that has repeated dozens of times during the Pleistocene has no reason to end simply because one species has built highways and satellites on the surface of the planet. The return is written in the tilt of the axis, in the shape of the orbit, in the slow wobble of a planet that does not know or care what lays upon it. We are living inside a return right now, a brief warm interval in a long cold story, and the fact that it feels permanent is only because our lives are too short to perceive the rhythm. The Cenozoic has always returned to what it knows. Warmth gives way to cold. Cold gives way to warmth. Forests advance and retreat. Ice expands and melts. Species rise and fall and rise again in different forms. The return is not something that happens to the Earth. It is something the Earth does as naturally and as inevitably as breathing one cycle, folding into the next forever, without end, without hurry, without any need for permission from the creatures who happen to be awake during this particular turn of the wheel. You have been lying still for a long time now, and the world outside your window has not changed in any way you can measure. The same air fills the room. The same gravity holds you to the bed. The same darkness wraps around the walls, and the same faint sounds, a distant car, the hum of something electrical, the settling of a house that has been standing long enough to forget it was built, continue as they did before we began this journey. Nothing has moved, and yet everything has shifted because you now carry inside you a story that stretches back 66 million years, a story that began in ash and silence, and built itself layer by patient layer into the world you are breathing in right now. The reflection is not something I will give you. It is something that is already forming on its own the way sediment forms at the bottom of a still lake, slowly, without effort, without anyone deciding where each grain should fall. The Cenozoic teaches many things, but the one that settles deepest at this hour in this quiet is the simplest of all, that impermanence is not the enemy of meaning. Everything we have walked through tonight was temporary. The forests that covered the planet from pole to pole are gone, replaced by grasslands and deserts, and ice that were themselves replaced by other forests and other grasslands, in an endless rotation that has no final form. The creatures that rose to dominance in each epoch, the pantodonts, the creodonts, the terror birds, the saber-toothed cats, the mammoths, each of them lived as though their world was the world, as though the conditions they knew were permanent, and the roles they filled were theirs by right, and each of them passed not because they failed, but because the world moved on and asked for something different. Their impermanence did not erase their significance. They mattered to the ecosystems they shaped, to the species they competed with, to the evolutionary paths they opened or closed simply by existing. They mattered the way a single breath matters, not because it lasts, but because without it the next breath cannot come. You are part of this same impermanence, and so is everything you know. The cities you live in, the languages you speak, the relationships you hold, the worries that kept you awake before you pressed play on this recording. All of it is temporary in the way that Eocene forests were temporary, in the way that Pleistocene ice sheets were temporary, in the way that every arrangement the Earth has ever made has been temporary. This is not a sad truth. It is a liberating one because it means that nothing you are experiencing right now, No difficulty, no uncertainty, no grief is the permanent state of things. The Cenozoic proves with 66 million years of evidence that conditions always change, that what seems fixed is always in motion, and that the silence that follows one chapter is always the opening of another. The planet does not end. It transitions, and so do you. There is also the matter of scale and what it does to the weight of things when you hold them up against deep time. The concerns that fill a human life, the deadlines, the disagreements, the small anxieties that accumulate like dust on a shelf are real, and they matter in the way that all immediate things matter. But they exist on a timescale so brief that the Cenozoic would not even register them the way an ocean does not register a single raindrop, even though it is made entirely of raindrops. This is not meant to diminish your experience. It is meant to place it to give it a frame large enough that the pressure eases slightly, the way a tight room feels less claustrophobic when you open a window and see the sky. Your life is a raindrop, but the ocean it falls into has been gathering for 66 million years, and every drop that came before you helped build the world you're falling into now. You are not small, you are specific. And specificity in a universe this large and this old is its own kind of magnificence. The Cenozoic also offers a quieter lesson, one that does not announce itself but settles into the body like warmth from a fire you did not realize you were sitting near. It is the lesson of resilience, not the loud, triumphant kind that appears on motivational posters, but the slow, unglamorous kind that simply continues. Life on Earth has survived 5 mass extinctions, each one capable of ending the story entirely. It survived the asteroid that killed the dinosaurs. It survived the thermal maximum that heated the planet beyond recognition. It survived the freezing of Antarctica, the advance of glaciers across entire continents, the disappearance of forests that had stood for tens of millions of years. And it did not survive by being strong in the way we usually mean that word, by resisting change, by holding its ground, by refusing to yield. It survived by yielding, by bending, by letting go of what no longer worked, and reaching toward what might. The small mammals that inherited the Earth after the dinosaurs did not fight for dominance. They simply occupied the space that opened, adapted to the conditions they found, and let time do the rest. Resilience, the Cenozoic suggests, is not about standing firm. It is about remaining soft enough to be reshaped without breaking. And so as the last minutes of this journey settle around you, like the final grains of sediment in a long geological column, consider this: you are lying in the Cenozoic right now. Not in its memory, not in its aftermath, but in its living present. The era has not ended. The processes that built the Himalayas are still at work. The tectonic plates are still drifting. The climate is still oscillating, even if human activity has added a new and unprecedented variable to the equation. The evolutionary pressures that shaped every creature we discussed tonight are still operating, still selecting, still pushing life toward forms that fit the current moment. You're not looking back at the Cenozoic from some safe vantage point outside of it. You are inside it. You are made of it. Your calcium and your carbon, your oxygen and your iron were cycled through Cenozoic oceans and Cenozoic forests and Cenozoic volcanoes before they were cycled into you. The atoms in your body tonight have been part of this story for longer than you can imagine, and they will continue to be part of it long after you have returned them to the soil and the air and the water from which they came. This is not an ending. The Cenozoic does not end. It breathes, and you are one of its breaths, brief, warm, alive, and connected to every breath that came before. The forests are in you, the ice is in you, the ash of the asteroid and the warmth of the Eocene and the patience of every small creature that ever survived a catastrophe. By simply continuing to exist, all of it is in you tonight, right now, in this room, in this dark, in this quiet. You did not come from the Cenozoic. You are the Cenozoic, its latest expression, its most recent word in a sentence that has been unfolding for 66 million years and is not yet finished. Let that thought settle. Let it weigh nothing. Let it hold you the way the atmosphere holds the planet gently and visibly, without any need for effort or understanding. The reflection is not something you need to grasp. It is something you can simply rest inside the way a fossil rests inside stone, carried forward by forces too large and too patient to resist. Close your eyes. The Cenozoic will carry you from here, We've reached the edge of tonight's journey, traveller. The road behind us stretches back 66 million years, through ash and forest and ice, through oceans that learn to carry whales and grasslands, that learn to carry herds, through the slow rise of mountains and the slower rise of minds, capable of wondering how it all began. It was a long road, and you walked every step of it in the dark, lying still, breathing softly, letting the weight of deep time settle over you, like sediment falling through quiet water. You do not need to remember any of it, not the names of the epochs, not the creatures that rose and fell, not the chemical signatures locked in ancient stone. The story did not pass through your mind tonight to be memorized. It passed through you the way rain passes through soil, downward, quietly into places you cannot see and do not need to tend. Whatever needed to stay has already stayed. Whatever needed to dissolve has already dissolved. The Cenozoic is not asking you to carry it. It has been carrying itself for 66 million years. It does not need your effort. It only needed your presence, and you gave that freely. In the end, traveller, it is all right to not understand. It is all right to let the ages blur, to let the forests and the glaciers and the small mammals in their burrows become a single feeling rather than a sequence of facts. Understanding is not the only way to hold something. Sometimes the body knows what the mind cannot name, and that is enough. Let gravity hold you. Let the questions fade. Let the weight of your bones remind you that you are made of the same stone, and mineral and ancient carbon that built every mountain and every living thing we spoke of tonight. You are not separate from the story. You're its most recent breath. Some mysteries aren't meant to be solved, only observed. Tonight the universe whispers again. Sleep, traveller. The cosmos will keep watch.